Welcome everyone. My name is Brian Griffin. I'm part of the SAP Global Specialty Practice for AWS, which is effectively part of our professional services organization. For the past 4 years, I've had the privilege of working with our largest customers and some of SAP's biggest customers on the planet. These are public production customers such as Kellogg's, Cardinal Health, Compass Group, and Lockheed Martin. On my current project, I'm working side by side with SAP and a global system implementer, working to do a greenfield S4 project. It's about a $500 million project for an oil and gas customer. I'm giving you a little bit of this background because I want you to understand what we're going to be discussing here is not theoretical. These are real things being done by real projects with real customers. Now, I've seen and made a vast amount of mistakes over the last 4 years in the journey to the cloud. I'm hoping that by going through this talk, you'll also be able to go through and learn vicariously through me versus going and living that yourself. And one more. And it looks like my slides are not right. Give me just a moment. Okay, so in the past and all the way through today, I see customers that are continually making one-way door mistakes. And what I mean by that is they're walking through these doors and they can't get back to where they've been and to their initial state very easily. Often this is characterized by mistakes in estimating and architecting the solution at the very beginning of a project where honestly you know the very least about your real requirements and what your actual capabilities are. Sometimes it's not something strategic. Sometimes it's something more tactical like a lack of training or proper guardrails in the AWS account. Has anyone here ever accidentally deleted an instance when they really meant to shut it down? Have you deployed an instance in a wrong subnet or with the wrong disk type? How about accidentally missing some OS parameters that end up resulting in system performance degradation, overall stability, or even worse, security issues? How about estimating? Who here feels confident that what they put in the SAP Quick Sizer is 100% correct, and over the life of that project, their requirements haven't gone through and changed over that multi-year duration? So at AWS, we offer you the chance to have two-way doors. We change the equation by allowing you to start experiments and then very quickly pivot if you find out that the experiments aren't giving the results that you're hoping for. I'll talk about how we technically do that a little later on in the talk as part of the operations piece. Now, to help you understand where we're going, I find it helps to talk about a little bit where we've been. Some of you may have seen a version of this slide, but like all things AWS, it continues to evolve and change. It is one of my favorite ones to talk about because it really crisply encapsulates just how far we've come in a short period of time. So AWS opened our doors, or rather our APIs, in 2006. The very first production service was S3, and then it delighted customers and really launched the AWS Cloud, which changed the technology space as we know it today. Since then, we've been building a robust, dynamic platform for customers to launch their solutions on, and one of those customers was SAP. SAP started in 2008, where they became a customer of ours. And then 3 years later, we cemented that relationship with a formal partnership in 2011. So if you've ever used the SAP Cloud Appliance Library, if you've ever taken a training class at SAP, SAP Tech Ed, or gone to SAP Sapphire, if you've used SAP Concur to enter your expenses, things like that, you've likely been running SAP on AWS and didn't even know about it. Now, I won't jump into what each one of these bullets are on the slope, But some key takeaways from this slide are that we've worked closely with SAP to certify all NetWeaver 7.0 applications and above, and these are production-grade certifications. We release and continue to invest in larger EC2 instance types, specifically instance types for SAP HANA, which we'll dive deeper into a little later on in the talk. And we're not just focused on the infrastructure. After all, this is the cloud. This is not just a data center. If you're using AWS as just a data center, you're doing it wrong. You are leaving a lot of innovation out on the table. An example of the non-infrastructure items that I'm talking about is one of the items that we launched at SAP Sapphire last week. Sorry, to add a slide. Sorry, we're having a little bit of slide issues. So we launched the SAP S4 Quick Start at SAP Sapphire. So what does that mean? It allows you to load your, there we go. It allows you to load your SAP software in an S3 bucket and then fill out about 53 different boxes and wait about an hour and a half to 2 hours, and you have a production grade ready S4 environment that your company can go through and launch on. This complements the existing standalone SAP NetWeaver Quick Start and SAP HANA Quick Start, which again are very, very heavily customizable. And you can look forward in the rest of 2019 for more Quick Start goodness specific to SAP in the second half of this year. What we've also been focused on is something I'll call the SAP Extend strategy, which is allowing customers to look at API integration of SAP applications to interface with AWS. We formed a strong partnership with SAP around their SaaS products like Concur, SuccessFactors, Ariba, Hybris, as well as many others. And the main takeaway from this slide is that SAP and AWS have a 10-year relationship where we have a very strong track record for hosting your most mission-critical SAP application production workloads. But don't take my word for it. This is our standard SAP NASCAR slide of all public production SAP references, of many public SAP production references. This doesn't come close to talking about all of our hundreds of enterprise customers that are running production on AWS, or the thousands of SAP total customers that are running on the platform. If you take a look at some of these names, you will notice some interesting things. The first thing to note is the depth and breadth of the industry coverage. Nearly every industry that SAP plays in, we have customers, many of which are quite large, trusting their mission-critical workloads to our platform across a vast swath of the SAP product portfolio. Whether it's BP or Origin in the energy sector, AIG or Compass AIG or Liberty Mutual in the insurance vertical, Kellogg's or Luxottica in the in the manufacturing vertical, Fast Retailing, which is also known as Uniqlo, or Brooks Brothers in the retail segment, BMS, Bristol Myers Squibb, Cardinal Health in the healthcare life sciences space, and lastly, in the public sector space, you'll see folks like Lockheed Martin, SAP, NS2, among many others. So at this point, these companies have already broken the glass in their respective industries and answered the questions that are, top of mind for CIOs, CTOs, CEOs, and that is, does it make good business sense to run my core SAP applications in the AWS cloud? Please let us broker a conversation with any of these companies, with your respective company, because the best way to hear about our platform is through the customer lens, something that we will continue to preach for the rest of this talk. Now, I'm very much a believer in the phrase trust but verify. Please do your research before you choose a platform. talk to existing customers, read trusted analyst reports. When analysts like ISG sat down and put together their provider lens for SAP HANA, we found ourselves at the very top right. And that's largely in part due to the innovative engineering advances that we've had, the strong market presence, and the customer support that we've received. This time of year, especially right after SAP Sapphire, there are always heaps of announcements that are going out about new partnerships or freshly penned press releases about future state capabilities. Marketing departments are very eager to go through and sell the sizzle. And I'm all for sizzle, but let's make sure that the steak isn't undercooked. Let's make sure that there are real production SAP customers that are going through and talking about the existing capabilities of the platform that they're using right now. After all, SAP is often the crown jewel of enterprises. It is what the core business runs on, and you want to make sure that that this application has a track record of success. Now, we do have a complete coverage of our SAP customer journey within our platform. We have an amazing collection of SAP and AWS certified partners. That's in that top right in the Enable section. And these partners are bilingual in both SAP and AWS. We have our SaaS integration, which we talked about, for customers that we know are going to continue to run hybrid cloud scenarios. So things like Concur, Ariba, Fieldglass, Hybris, all that sort of stuff. We have our latest certifications down the bottom left in the digital core. So we support Suite on HANA, S4 HANA, BW for HANA, all the latest and greatest innovations from SAP. And if you haven't decided to make your HANA journey yet, if you're still thinking about it, we absolutely go through and support all of your standard databases. So your DB2s, your Oracles, your SQL servers, et cetera, SAP ASC, all of those you can absolutely run, lift and shift, and move those onto our platform. But the piece that I'm most excited about is the piece in the upper left there. It's the extend. And why I'm so excited about it is we've made some recent announcements. One of them was SAP Sapphire last week. SAP and AWS have joined have a joint partnership and have launched interoperability between SAP's Leonardo IoT Core and AWS's IoT Core. Sorry, SAP's Leonardo IoT and AWS's IoT Core. So unlike most announcements, this was GA last week when it was announced, which allows for native cloud-to-cloud integration. This allows a thing to say, hey, I am not working correctly. Please, can you come and check me out? So for example, in our booth, we had a demo showing a conveyor belt that is hooked up with Amazon IoT Greengrass. And this IoT Greengrass had sensors on it that could go through and measure a whole host of things, one of which being vibration. So when someone would intentionally cause vibrations by stopping that assembly line, not only did it automatically fire a maintenance order into SAP for the replacement of a part, but it uses AWS Sumerian, which has 3D modeling capabilities, to show the technician the area where the issue was coming from. So imagine how powerful that would be where a technician shows up on site in the field without a training manual, shows up with the right tools, with the correct part to fix it, and has a demonstration right there on his iPhone or mobile device to go through and talk about what needs to be ordered. This is what SAP is talking about when they're talking about the intelligent enterprise, and it's powered by the cloud. The next few slides are going to go through and talk about some of the latest engineering advances, and then we're going to get into the operations piece. Well, we want to talk about the engineering advances because they are true differentiators for our platform. When I started in 2015, this box to the left, 244 gigabytes with 32 vCPU, that was the largest instance type we had available. A year later, we had our real seminal moment where we launched the we launched the X1 platform, which is powered by Intel's Haswell v7 processors, which was at the time the largest native cloud instance, virtual machine. And it had 2 terabytes of memory that you could go through and use. We also could take those 2 X1 instances, put 7 of them together, and scale that out to 14 terabytes. We very quickly followed that up with our X1E platform, also powered by Intel Haswell v7, and those had 4 terabytes of memory on them, which was large enough to address 95% of SAP's overall total HANA customer base. Now, we're AWS, and we don't want to just serve the 95%. We want to go through and serve the most demanding customers on AWS, the very largest customers. And we heard from those customers that we need a roadmap for larger instances. They need a commitment from us to show them a runway before they would go and start launching instances on us. So we listened, we went back to the drawing board, we got together with Intel, and I'm happy to say that customers now launch instances on 6, 9, and 12 terabytes. Those are all scale-up instances. We have also promised to release, you can't see it in the slide very well, but 18 and 24 terabyte single node instances. So these are great for applications like S4HANA, Suite on HANA, and we'll continue making innovations in this particular space for the years to come. One thing that is interesting, if you kind of do the math, and that means in the last 4 years, we have grown our EC2 maximum instance size for memory 100-fold. That is the power of the cloud and the pace of innovation that you typically see from AWS. Now, having very large instances is one thing, but at some point it just becomes an arm race between providers to go through and say, we have the biggest or we have the best. And that's not something that is really moving the needle with customers. What customers want to know is the differentiating factors between those particular instances. So let's talk about why these instances are different from what you'll see in the marketplace. With our partner Intel, we created these instances which were purpose-built specifically for HANA. They are EC2 bare metal instances that run on dedicated hosts from within the Amazon VPC. They run on our Nitro platform, so there is a small hypervisor there, but they have the bare metal experience, meaning you can go through and toggle things at the the bare metal level. Just a second. Go back a slide. This is not a co-location facility. These are not instances that are set in a separate data center that you have a fat pipe to that are tens of milliseconds away from your application servers. These are instances that are within the same network fabric. They are using the same AWS native services. They integrate with all 180 plus native services that AWS has, the same exact IAM security, the same exact way you can launch via the APIs or through the SDKs. These are real cloud instances. And it's a really important factor because when you start changing into this hybrid model, what ends up happening is native features from SAP, such as HANA system replication, you start having to do some network tomfoolery just to make sure that works when you want to run HA and disaster recovery, because you're having to go through and forward package from place to place. So now you're changing the application to meet your architecture, and you don't want to have to go through and do that. You'll also go through and you'll see significant performance differences if you start having your database in separate locations, data centers, than your application itself. For some reason, this is not transitioning. Okay. Also proud to announce some other engineering efforts that we have. One of those is that very recently we have certified SAP S/4HANA to go through and scale up to 48 terabytes. So if you're not familiar, SAP has allowed HANA, S/4HANA specifically, to go through and scale out. Traditionally, you don't want to do this with OLTP systems, but they recognize you don't want to continue to scale up and have a bigger and bigger and bigger basket. And what does that mean for you, for customers? It means that this, again, is 100% cloud native, works with all of our individual services, and you can scale from a 1 terabyte instance to a 4 terabyte instance to a 24 terabyte instance to a 48 terabyte scale out instance. Do that all on the fly. And what I mean by that is this is something that is software defined. This is something that you don't have to go through and purchase weeks and weeks in advance. So all of the benefits that you came to love about the cloud, they're also available for these particular instance types. If you're also familiar with how hardware is ordered, usually when your applications are scaling linearly, if you're doubling the amount of capacity, the price is not actually scaling linearly. The price is going through and going up exponentially. But when you have a model like our 48 terabyte, where we've put together 4 12 terabyte instances, it allows you to procure hardware where the pricing stays very flat. The more sockets you need, you're not having to expect the price to double over the equivalent scale-out memory footprint. And lastly, speed. When you want to go through and cut over from place to place, when you want to be able to jump from instance size to instance size, you have that flexibility, and you can go through and do that in minutes. And finally, if you were a customer who felt constricted by our previous 50 terabyte scale-out for OLAP, have no fear. We've certified our X1E platform now to scale out to 100 terabytes. We don't usually see many customers that are looking to do that at scale, but if you are interested in doing that, we certified it with a TDI 5 model. We'll work with you and SAP to make sure we go through those requirements and that workload is supported. Okay. So we said this session was going to be about operations on AWS, and since I'm a consultant, I'll kind of talk about some of the tools that we use day in and day out on the projects. One of those things is the SAP Quick Starts that we talked about. First, we have the 3 Quick Starts, the HANA Quick Start, the S4 HANA Quick Start, and the NetWeaver Quick Start. These are, again, very highly customizable. I've taken this in my current project and integrated this with ServiceNow so that basically our basis team will come through and they'll have some drop downs in ServiceNow. It'll fire off a JSON payload. AWS CloudFormation will pick up that payload and instances will start being deployed according to the drop downs that they have. So that is real world production integration with an existing service catalog. If you want to use AWS native services, you certainly can do that. We use CloudFormation as our primary way to go through and deploy infrastructure as code. You can use anything you like, Ansible, Terraform, all of that good stuff, all supported. With the capabilities of infrastructure as code, what do I mean by that? Well, it means that customers in very highly regulated industries, places where you need to go through and pass audits, where you have to pass GXP compliance processes, it makes this a breeze. And why is that? Well, when an auditor comes to me and says, how did you build this environment? What were all the steps? And prove that it went through the same between dev, QA, and production, I can hand that auditor my code and say, this is the code and these are the parameters that I passed to it, and here's the proof that it is done this way. All of my basis brethren love this because when you want to stand up the exact same instance, but you just want to do it in a separate availability zone, or you want to move this to a separate region, it's a very simple change to go through and change an AZ or region parameter from within that code. It's a one-line change. And obviously, these things are very customizable to the sense where if you want to scale these out, if you want to have multiple application servers, if you want to have them in the same availability zone or multiple availability zones, set them up for HA or not set them up for HA, set it up for a third tertiary disaster recovery site. Those are all things that are possible with the existing quick starts. So another piece that something that is uniquely AWS is something that we call a serverless refresh. And what do I mean by that? Well, first let's talk about what a refresh is, right? So for folks who've run SAP for a long time, you're very familiar. The problem is that functional teams and ABAP developers want to test their configurations and their code against real data. And over time, data in non-production systems can become stale or can become, quote unquote, used up. And it means that their tests that they're running against it are no longer valid. So obviously, the reason you have non-production systems is because you want to be able to test before you go to production. So what do? We go through and we take a production database and we copy it back over your QA databases, and you're doing all of this because you want to be able to test. This is not something that's innovative. This is not something that is moving the needle forward for your business. This is 100% administrative. So what are the problems we see to this? Well, first, you have to coordinate a bunch of teams. You have to coordinate folks from the basis team, from the storage teams, the DBA teams, all make sure they know when and how they're going to do the work. It's very, very time intensive. It usually takes one basis person allocated to one SAP product anywhere from 2 to 5 business days to go through and complete just the post-refresh steps. If you've really, really optimized it, then maybe it takes 2 days, but again, it's one resource to go through per system. And if you have a very large landscape, you're losing a week out of your basis team's time. And if you're doing this quite frequently, which a lot of customers will do this every quarter, that time really starts to add up. Furthermore, if you're in a project scenario, this requires downtime from the business because your QA systems that you are refreshing with your production data, they are put on hold. They are moved off to the side while you're doing this refresh process, which means that it's very, very intensive from a resource perspective. So I've been on multiple projects where the burn rate for consultants and project resources are well over $1 million a day. You want these people to be engaged and working in a system. You don't want them waiting a week for the refresh process to happen. And with the serverless refresh, we've solved a lot of those issues. So what we do is we've strung together a bunch of AWS native services. The three, features are AWS Lambda, AWS Step Functions, and AWS EC2 Systems Manager. Lambda, for those who aren't aware, and most SAP folks aren't aware, is something that you'll hear the market call function as a service. Effectively, you put your code in the Lambda service. It takes a number of different types of code, and you hit the execute button, and AWS matches up some infrastructure to go through and run your code. So you're not worrying about managing servers or patching those servers. You are being priced based off of how long that particular line of code runs, as well as how much memory it uses. And I think you get something like 1 million lambdas in your account for free. So this is something that is exceptionally, exceptionally cost effective. The next piece is AWS Step Functions, and those step functions, basically think of that as a workflow. So you have these lambdas that go through and run, but these step functions go and coordinate all of the different pieces. It also breaks it up so that if you have a step function that fails, you can go through and just rerun that step function so it remembers the state of where you were last at. And then lastly, EC2 Systems Manager, which will go through and allow you to do many operational tasks. You'll get to see Systems Manager in the demo that we have at the end of the session. Okay, so let's take the typical scenario of you putting your production data in your QA database. The first step is to make sure all the details, is to save off all the details of that particular system that you want to go through and save. There are fields in an Excel spreadsheet that we have that will go through and allow you to save things like transports that you'll need to re-import back into the QA environment. This happens because when you refresh production over QA, there's quite frequently QA transports that haven't made it all the way there, so you don't want to lose those. So we go and we save those off. Other fields like RFC destinations, printer configurations, usernames, number ranges, indexes, all of that stuff, all of those things that you traditionally want to save in a refresh are all captured as parameters and stored in AWS parameter store, and we load these up via we load these up via a script. The next step is to point your Lambdas to the S3 location where you have your standard HANA backups. You just need your standard HANA backup data files. You point the refresh process to those, and you are good to go. Next, an AMI is taken of the existing QA environment. An AMI is an Amazon machine image. It's a snapshot of that particular image, and it is moved into its own isolated network. So it's separated from the original SAP network, so you don't have to be concerned about crosstalk. This is actually a significant pain point for customers. If you've ever tried to manage your firewall configurations on-prem, or to go through and make sure you have all the steps so that a batch job doesn't fire off and start processing real customer orders, or cross-talking, picking up other integration scenarios. I've had that happen in a previous life. It is not fun when your non-prod systems are thinking they're production. So this goes through and prevents you from being concerned about that. Now the next step is to go through and take this AMI and run the BDLS process, because right now it still thinks it's production. You run the BDLS process, which is standard SAP functionality, and this is something that the Lambda functions go through and do for you. And what's great about it is it orchestrates all the particular steps that you need. And if at any point in time it's going through this BDLS process, it runs into an error or any of these steps don't finish, then what happens? You get automatically emailed via SNS or SMS. You could get a text message letting you know that someone needs to log in and check and see why this is going on. Usually that happens the first couple runs, then after you figure out how to use the tool set, then you're good to go. And you can do multiple systems all at once. When the refresh is finally complete, then you have the option to either just flat out switch your new QA environment into the old QA environment, or you have the capability just to go and take a standard backup from this new QA, overlay it onto the old QA, and your end users are ready to use the system. We're talking about outages measured in minutes. So this entire refresh process, I typically see customers taking anywhere between right around 2 days for all of their overall systems. But again, this is being managed by a resource or a very small amount of resources, and is very, very time and cost effective. And best of all, it's not using any licensed products that you have to maintain or pay maintenance over for multiple years. It's 100% customizable, so if there are steps in the refresh that you also want to go through and automate, you can go and do that. This is not something that's a pet project. This is something that we're deploying at customers right now. This is my architecture video Amazon's posted of Zalora, which is one of Asia's leading online fashion retailers. And they saw that their time frame for their system refresh went from about 5 days to 2 days, and it's being managed by significantly fewer resources in the process. Meanwhile, functional teams are still actively using the original QA while this whole thing is going on. So really, really neat tool set. And again, no servers, no additional servers you have to administer. You're not installing agents on all the different boxes. Reduces the human error, reduces human think time, and when basis teams get busy, a lot of time that's spent on these post-configuration steps is not clicking buttons, it's actually someone coming up and asking them to go and do something else. So it removes that burden. All right, and let's see if we can get this demo to work. Awesome. So I talked about a lot of different things. One of those things was the AWS Quick Start. And I mentioned that the Quick Start can go through and stand up an S4 environment. So I've gone through, let's make this a little bigger. I've gone through and done that. What I've stood up is effectively this. I have RDP server in a public subnet. I have an ASCS and a standby ASCS in a separate availability zone. Availability zone is a separate data center, but they're all part of they're all part of the same region. So it is designed so that you can run synchronous, or in SAP HANA use cases, we like to recommend use sync-mem to do the synchronization from place to place. And for the ASCS ERS, it'll go through and manage that replication. So this is the setup that we have. Automatically, the Quick Start, I've chosen to set it up for HA. For folks who haven't set up HA in a clustered environment, it is not trivial. It is something that can be resource intensive. It's something that is very finicky in the sense that you have to pass exactly the right parameters, and it does take some time to go through and set up, especially if you want to go through and do this at scale. This goes through and sets that up for you, which is hugely beneficial. And also the way that you do high availability on AWS is slightly different, because if you're doing it on-prem, you're likely doing it over layer 2 networking, and in AWS, you're doing it in layer 3 networking. We have something called an overlay IP address, which I could spend a whole session talking about, but suffice it to say, we have the capability to lose an entire data center with this architecture, or in our case, an availability zone in this architecture, and still be at 0 data loss. Now, if you take a step back, does that happen in your existing architectures today? Could you lose a data center and still be at 0 data loss? Or more likely, would you immediately go to your disaster recovery solution, which again means that there's RPO involved, often in a number of hours, and this is not a technical solution. It is a solution that the whole business has to buy off on. In this scenario, using SUSE HAE, we can fail these HANA servers over in roughly 4 to 5 minutes when it experiences a drop, and the ASCS and ERS are usually a matter of seconds. We can do that from within the software, or we can do that just by pulling the plug on the server. So we'll go through and we'll demonstrate that. So I've stood these up, and you'll see I have the ASCS in US West 2A, and a standby ASCS, which is in US West 2B. My HANA server is in A, and my secondary server is in B. So for folks who haven't seen, this is what SUSE HAE looks like. You can see that the primary IP address, the virtual IP address that all the connections are talking to, are sitting in West HANA. It says West HANA Pri, it's the primary side. And you can see so that's where the IP is. This is where it recognizes HANA is. And for proof, here is my HANA console. So you can see all services are active and in sync, and I am running on US West 1A. Now, what happens if something bad happens? We know that failures happen even within AWS. If I go through and I just do this, what's the cluster going to do? Well, the first thing the cluster is going to do is it's going to recognize, hey, there's a problem. And it immediately moves the IP address over to the secondary side. The IP address is already there. I'll prove it to you. Here's a secondary HANA. If I do IPA, this address right here at the bottom, this is your overlay IP address. It's outside of the network CIDR block range. Your applications are already starting to point to this. Now, what do end users see? End users you've not lost any data. End users will see some rollbacks of existing batch jobs. But most end users, if they've hit the enter button, they're just seeing a spin. So they don't know that something's happening. in the background. I can see that the primary replication, so replication has been turned off, and the primary is now moving to West HANA, which is in the secondary side. And this, for folks who see the Stoneth, this is the way that SUSE manages split brain scenarios. Stoneth is an acronym. It stands for shoot the other node in the head. And what that means effectively is that if it ever recognizes that both sides are raising their hands and saying that I want to be the primary, it'll go through and make sure that that doesn't happen. So we have our little blue ball here, which you can't really see on the screen, but effectively that's telling you that your HANA system has failed over appropriately. So let's go and let's verify. So this is my original HANA. You can see here, this is the secondary side. I'll double click on that and bring it up. And there we go. All services started, the same exact size. And you can see the landscape, it doesn't have, it's not replicating anywhere else. What's really cool is I can go through and fail that back the opposite direction. If you've ever had to do some of this, you'll know that it is very intensive from the command line to go and pass the right parameters. They're very, very long strings. SUSE has made it nice and easy for you to go through and automatically replicate back the other direction as soon as it recognizes that that instance is available. I'm going to hold off on that for now because I think you guys get the idea. Some other pieces which we talked about for with AWS is automating processes for standard operations like resizing an instance or shutting down servers at a certain period of time. So let's use AWS System Manager to do a couple of those things. First, I'm going to show this because I think it's really cool, and I use this just about every day. This is something we call Session Manager. It's part of Systems Manager, but if you don't want to log in, you don't want to log into a server, you haven't configured it in PuTTY or whatever terminal you log into, you just want to log in point to point, or you want to have really, really secure connections. You don't even want to open up port 22. Seems very rare that that would be a case, but quite frequently, if you have a landscape of 200 servers, going and just logging into an instance can be somewhat annoying. So if I want to just check and see, hey, how is my HANA secondary doing right now? I choose it, I hit start session, and instantly I'm logged into the box. I've not logged in through SSH, I've logged in through the session manager. So it's super, super secure. All the commands that I type in here are now logged in S3 so it can be audited. So if you want to give someone temporary access to a particular box, you can give them access to Systems Manager and they can go through and do that. And you can see I'm logged into this box, and if I run some commands, there you go. So another way to go through and log into the console, also through Systems Manager. But Systems Manager has some other really unique features. So a scenario that I use on my project all the time, they have a SLT, it's a greenfield implementation, and they're pumping in a significant amount of data from on-prem SLT into AWS, into their S4 system, because obviously they want to keep some of those financials. Well, this process is a one-time process. Let me rephrase that. It's continually run, but will not run after we go live. But up to the point that we go live, we want to be able to run this process in a wide open fashion. And why is that? Because it is exceptionally resource intensive on the CPU. So what was happening on the project previously is we had M5 2x larges, and I think that's like 8 vCPU and 32 gig of RAM. And what is happening is that those processes are running for 12 hours. So they said, let's use the power of the cloud. Let's resize those things to M5 24x larges, make them 12 times bigger. Let's see if they go 12 times faster. Sure enough, we did that. It ran faster than 12 times. It was faster than 12 times time savings, and it was something that's done at the click of a button. So let's do that through some automation through Systems Manager. So I'll come in here, and I will go to automation. And these are pre-canned automations. This is something that you can go through and create yourself. You can create your own custom automations. So what can you do with that? You can go and you can patch kernels. You can go through and you can upgrade HANA databases. I think right now we have, 64 different database instances in our environment. Going through and patching those from one SP level to another SP level, it's going to take a little while. What if you could go through and do it all at once? Or you could do it in sections. So I want to show you kind of what I'm talking about. So let's go into AWS resize instance. Make this a little smaller. Now I just want to pick the instances for now. I'm going to control the rate, and I want to say, I'm going to choose by instance ID. And here are some of the instances in my account. I'm going to take this ASCS and let's say the other ASCS. So right now, you'll see that those are running on an M4 large, and another one is also on M4 large. So I want to make those 16 times, actually 32 times bigger than what they currently are. How long is it going to take for us to go through and do that? I would estimate this is going to take about 5 minutes. Let's see how fast. Yep. I'm getting time called, so give me just a moment. So M4 16x large. And I will say I want to do 2 of these at once. I will give it up to 2 airs. And I've chosen the 2 targets that I want to do this for. I'll hit execute. And it starts running a script. Now what's going to happen? You're going to see these 2 instances. There they go. They just start stopping, and they're in the process. 5 minutes later, these things are going to be 32 times larger than what they were before. So what my current customer has done is they've put SAP shutdown scripts as part of the instance shutdown. So they don't even need to stop SAP because the shutdown scripts, at the point of a AWS CLI call, it goes through and it shuts those down cleanly and gracefully, and then it'll go through and do this resize. We consistently do this on the project, and what that means is we have a bunch of consultants that are fully engaged. They're not waiting 12 hours at a time for these long load times to run. They're able to shorten that window to about an hour. It takes about 5 minutes for this to go through and be active. We have to start our SAP applications back up, and we are good to go. And the cost for this is a matter of dollars per hour. So I think in our environment, we estimated that for less than $100, we're able to turn the servers on for 2 days of that exceptionally high run rate, and then scale them back down. That is something you can do with the power of the platform. Fantastic for things like upgrades, cutover windows, a whole host of applications to be used. And I think that is about it. If you have any questions, feel free to talk to me after the session. Again, my name is Brian Griffin. I'm with AWS Professional Services. If you or your customer are looking to go through and migrate your SAP applications to the cloud, please talk to us. We'd love to have a conversation. Thank you.